So our team was tasked with helping clean up the Shamokin PA watershed, which has been heavily impacted by acid mine drainage from abandoned mines in the area. We primarily focused on two specific AMD discharge sites, Cameron Drift 51A and Cameron Air Shaft 53. These areas were contaminated with water, which is entering the environment. The main challenge was designing a cost-effective water treatment system that could clean the water and support the restoration of aquatic life in the area. This project required careful engineering analysis to balance treatment effectiveness and the site conditions, as well as long-term sustainability.
Yeah, so seen here, there's a water quality table for it has combined flows from both Cameron Drift 51A and Cameron Airshaft 53. Um, and with this table, we're able to get a pretty solid foundation of what the water treatment plant should look like and what it should have based on the pH of the water, the intake of the water, and how much iron is in the water. So there were 53 samples for 51A and 6 samples collected in this table for 53. Aircraft 53, and that is how we have came up with the design for the water treatment plant.
The first part of the investigation was to find the different locations for to display the different locations for the acid mine drainage and our potential water treatment plant in Shamokin, BA. The first thing we did was a subsurface investigation. The mine map here is under Shamokin Creek. You can see there's a various different outlets of mines under Shamokin Creek. And next, we looked at the topographical area to see the elevation and where the water flows for our two locations of Cambridge Drift and Air Shafts 51A. Next, we found where our potential waste treatment plant should be and decided to choose to put it next to the uh, prison there. And because that's like the clearest area that we have within the 2 miles.
And then finally, we're going to use this treatment train for the plant, which is going to include a blending tank, going on to decarbonation, neutralization using hydrated lime, reaction tanks to react the lime with the influent, treat it with polymer so it flocculates in the clarifiers, and then finally it will be discharged to the wetland for polishing. Our capital cost will be around $9.9 million with an annual cost of $732,000. And the total area required for our project will be about 2.6 acres. We'd like to thank the Pennsylvania Department of Environmental Protection and the creators of AMD Treat for providing the essential tools for our project. And special thanks to Dr. Burgos for his guidance throughout this project. We look forward to seeing you guys at the end.